My talk is don't be afraid of the JavaScript stack trace. How many of you are programmers? Okay. How many of you do JavaScript development? Okay. How many of you have ever written code that had bugs in it? Okay. Well, I don't normally do that, so I took some things that my coworkers do and put it into my presentation. But to get going, my name is Jennifer Bland. I am a senior software engineer for Stanley Black & Decker. You may have heard of Stanley. We make the hammers and the tape measures. If you have any type of electronic tool, it's probably a brand that we own because we own all of them except for two. So if you own Ryobi, DeWalt, Craftsman, of course the Stanley brand, we own all of those products. And I work on what is their Industry 4.0 initiative. So if you're not familiar with manufacturing, you probably have never heard of that term, Industry 4.0. But it's supposedly the fourth revolution, industry revolution, mainly for the industrial environment, for factories and whatnot. And what we're doing is we're going through when we're creating websites, basically an app market for all of Stanley's factories worldwide, so that they can be able to improve the performance that they have in our factories. We have 115 factories worldwide, and our goal on our team is that we're tasked with saving the company $300 million this calendar year. So that's what our applications are doing for the company itself. I'm also a Google developers expert in the web technology arena. So to start on my presentations, I always do this game that's called 3 Truths and 1 Lie. There are 4 items here on the screen. 3 of these items are true about myself. 1 is not true. So I'll just read them off. I've climbed the highest mountain on 4 of the 7 continents is number 1. Number 2, I graduated university with a 4.0 GPA. Number 3 is my home is 400 square feet. And number 4, I have been to 82 countries. Now, if you think about it, 3 of these items about myself are true, 1 is not true. At the end of my presentation, I'll go over it again, so I'll give you time to marinate and think about which one you think is not true. If you want to find out which one is not true, you have to stay till the very end of my presentation to find out. So to get started, to talking about the JavaScript stack trace and debugging your code, I want to start off with giving you some background terminology because you have to understand these terms first so that you can understand how the JavaScript stack trace works. And so going on with doing the background terminology, let's start with the basics. You know, what is JavaScript? And when you look at what JavaScript did, it's a single-threaded, single concurrent language. And what it means is it can handle one task at a time or one piece of code at a time. And what we have here, the image on the right side basically gives you a visual diagram of what's called the concurrency model in JavaScript. And the concurrency model is built up of the call stack, the heap, and the queue. So I'm going to go through and explain those 3 individually. So starting with first, we have what's called the call stack. And the call stack is basically, it's a stack. It basically operates in a LIFO, last in, first out principle. And when you start doing executing of your code, things are pushed onto the stack. And when they finish completion, they are removed from the stack. Things are added to the stack from the bottom, and they keep building up to the top. And things are executed, whatever's at the top of the stack gets executed on first, and then it's removed. Then it does the next thing, and it keeps going down the stack until everything has finished. So what I have here is some sample code on the screen. And what you see is it starts down here at the bottom where it has this console.log. And it's console.logging the output from a function called bar. And it's given it a parameter. And the way that this works, and I've got this animated, is it will go through, and it first starts off with main. You see the console.log pushed onto the stack. That calls the bar function. The bar function is put onto the stack itself. And then what it does is it does the return foo. So foo is now pushed onto the stack. That's done, and when the function finishes, foo is removed from the call stack. It returns to bar, which was its calling function. That completes, it's removed from the stack, and then it returns down to the console.log, and then the code stops running. So when you start seeing things in a stack trace, this is the order in which the thing's executed in order to get to a certain point in your code itself. So the next thing that we have, a part of the concurrency model, is what's called the heap. And the heap is, and for very simple terms, is just the amount of memory that's been assigned to your application. You might have ever seen where your application might crash because you ran out of heap space, you've ran out of memory. Every time that you create a new variable, every time that you create a new object or you create a new function, memory is allocated to that variable or to that object or to that function in the heap itself. And then as it's being used, when it finishes, it removes it from the memory that frees it up for something else to be able to use it. So that's what heap is that you're going to be doing. And the heap will keep adding things and removing things as things are going through the call stack. And then the last thing that you have is you have your queue. And basically what the queue is the line of things that need to be executed inside your code. When you have a normally running JavaScript application, it will start at the very top of your code and continue down until it gets to the very bottom, and then the code ends. And what that does is the queue is basically saying this is the next thing that needs to be executed, the next thing, and the next thing that are going on. Now, sometimes when you're executing code, you might end up with something that's an async function. An async function is it basically says, I need to go out and maybe get data from the server and return that data to the application. Well, the application will keep running while it's waiting for that call to get that data from the server. And once the data comes back, it lets the system know, oh, I now have the data. So it'll stop what it's last doing. It will come back into your code, get that data, and then handle it. So it might be moving back around as it's executing, and that's how async functions are done. And since the way it's done that way is because JavaScript is a single-threaded programming language. So when you do something async, it pushes it over into another thread to be handled, and when it finishes, it just alerts the main thread, I'm done. It'll finish executing what it's currently on, then come back to you, and then do that response that you have on there. So when you look at what's going on in the stack trace itself, it's going to give you a lot of information about your code and its execution that it's gone through. The main thing it's going to do is it's going to give you a list of all the functions that have been called and what order they were being called, because remember the stack trace is a queue, and it executes on a last in, first out method. So the first thing that's called is at the bottom. The next thing is on top, and it keeps doing it. And when something finishes executing, it pulls it off, and then it goes to the next thing. It pulls it off, goes to the next thing, and everything else like that. The stack trace will also tell you inside the file where the code is executed, the name of the file that it was executing from. So it'll give you the name of the file. It will actually give you the line number in that file, so you can actually go directly to it and find out where it is. And if you were using, let's say, a function, it will tell you what arguments it was used to be passed into that function. So a stack trace can give you a lot of information about the execution history of your code. And if something goes wrong, you can look at that stack trace and see how far it got, and then exactly where it died from, and then you can use that process of doing some debugging. So here is a demo of what a stack trace looks like. So if you have a very simple Very simple demo application. Down here you have 3 functions. You have a foo function, a bar function, and a baz function. And at the very bottom, I actually execute the function baz. So what you'll do is you'll see it will call baz, and on the far right side is the actual stack trace. And it starts from the bottom and goes up. So at the bottom, the first thing that you might see is anonymous function. And you're like, I don't have an anonymous function. I have foo, bar, and baz. Well, what happens is that most things execute on what's called the global scope. A lot of people refer to it as the window. So the anonymous function is because we're starting at that global scope, which is the window. So that's where baz is being executed, is in the global scope itself. So you have the anonymous function. The next thing that's put into the stack trace is the baz function. So baz, the function itself, calls the bar function. So that's the next thing that's put into the stack trace. Bar calls foo, which is the last thing that's put into the stack trace. And then inside the foo function, I'm actually just throwing an error so that it shows up in the console so that you can see this stack trace of what's going on. And if your code ever errors out or has a problem and you look in the console, you will see a stack trace like this where it actually will go through and show you what was running and at what time. And on the far right-hand side, it actually shows you the file name where this code was being executed. And in this case, it's a simple file that I just have called oops.js. And then it will tell you the line number. So the number after the colon tells you the exact line number. So when you look at it, you can go in there and you like, oh, it died in my oops.js file on line 2, and you can go there and you can try to see exactly what's happening to be able to do it. Now, once you know that your code has an error message, one of the things that most people do is they end up putting console.logs in their code to see what's going on. How many of you have used console.logs in your code for debugging? It's a pretty common thing that people do. There are actually 5 different levels of debugging that you can use on the console method itself. Besides the console.log, you have a console.debug, a console.info, a console.warn, and a console.error. So they all operate exactly like the console.log function. And there's a little bit of differences between the output that you get between all 5 of these levels, and they're different based on which browser that you're using, and I'll show you how that works. So to give you an example of what this looks like, if you have a very simple function, and I have in here a function called log them, and I have all 5 console methods in here where it actually will show you what it actually looks at. And at the very bottom, I call that function. So this is a very simple JavaScript function. And then to be able to see what that looks like is you end up having a very simple index.html file. In my head, I've imported in this file that I've had called logging.js. And then I have just something that shows up on the screen that tells you to open the console so that you can see what's going on. So this is what it looks like when you execute that command in Chrome. Now, in Chrome, you may not see the console.debug because the default setting in Chrome doesn't show debug messages in the browser itself. So I'm going to show you what it looks like, and I'll show you how to set that setting. But the main thing that I want to point out is of these 5 different console methods that you can use for debugging, the way that they differ, the console.error gives you a red background, so it clearly shows up in the log that you can see. Its text is red, and it puts an icon out on the side to let you know that there's an error. It puts icons on the console.warn and the console.info also. The console.warn gives you a yellow background so that you can easily see that in the log itself. And then the console.debug is blue in color. It used to be blue. They've changed it, and it's just a plain color that you have that's on there. So let me break out of here. I'm going to come back over. I have this one file, and I'm going to undo it. And if I come over here and I refresh, this is what you're going to see is these are the error messages that come in. Here's this one level right here. Normally, the default value that you have in your console is that you have is the default level, and verbose is not checked. And when you have verbose not checked, you only are going to see 4 of the console methods. If you change it to verbose, you'll now see the console.debug. So if you are using Chrome and you're using the console.debug and they're not showing up, then just make sure you look at that setting, within your application itself. Inside your browser. So let me continue on. So this is what it looks like in Chrome. How many of you use Chrome as your primary browser? How many of you use Firefox as your primary browser? Okay, Firefox, if you run the exact same file in Firefox, you get the same output. It looks differently. What Firefox does is when you do any of the console methods, it actually prints out all the text in the exact same color. There's no background color. There's no coloring of the individual letters of the text itself. Everything's the same color. What they end up doing is they end up putting icons next to 3 of the 5 levels to let you know that there's something that's on there. So same functionality, it's just how that looks in the console is a little bit different between the 2 browsers. Now, there's actually a 6th method that you can use on the console that a lot of people aren't aware of, and it's called console.table. And what console.table does is that if you do console.table and you give it an array, it will actually display the array for you in a table format. If you do console.table and you do an object, it will actually display the object directly for you so that you can see that. And it works with both arrays and objects. So let me stop here. I'm going to come back over to my code. And down here is I have an array called animals that it's an array of 3 objects that are in there. So normally what a lot of people will do is that they just do console.log and they put in that array that they want to do. So if I refresh, actually, let me come back over to my code, comment this out, refresh. Normally when you do a console.log, in order to see what's in there, you're used to having to drill down. So you have to click on this. You're saying, okay, it's an array, 3 objects. Now I have to drill down again, and only then do I actually get to see the content that I'm trying to be displayed in my terminal. And that's something that a lot of us have done when we've gone through and we've done a debug. If we come back over, and let me just uncomment this one line out. So I'll do the console.log, which is what most people will normally use, and then I'll do a console.table, come back over, refresh. This is the old way where you have to drill down. This is a much better way of being able to display the information that you have. And what you've done by doing the console.table, this is showing you doing the console.table with an array. And what it is it'll show you 0, 1, 2, which are the default indexes of an array. And then here are all the objects. So here are the keys across the top, and here are the values that you have that you can see that whatever is in there. So this is a lot easier when you're trying to display things than if you actually go out and just do a console.log and then have to click on things and move it. So what we did was I showed you what it would look like if you were doing it with an array. So we have an array here. So let me comment out these 2 lines again. And then down here below, I have an object called turtles. And in this object, it is an object full of objects itself. So each key has its value, is an object itself. And then normally if we wanted to see what it would look like if we did the traditional console.log and come over refresh, we have the same thing where we actually have to drill down. Instead of an array where we have 0, 1, 2, the indexes, we actually have the keys, and you have to drill down, and I'm actually able to see the content of what it is that I'm trying to console.log. Now, if I console.table an object, refresh, this is the old way, this is the new way. Instead of getting the 0, 1, 2 with the array, you get the actual keys that are inside the object itself, and then you actually get the values. This is a much better way to display things, but you have to think about, well, my data has arrays that, or has objects that has a lot more keys than what you have right here. Excuse me. So you're like, okay, well, this would just, be scrunched down if I'm trying to get it displayed on the display. So what you want to be able to do is be able to control what you actually are displaying. So if you come back over here, console log this out, console.log this. When you do a console.table, you give it the name of the variable or that you want to actually be displayed in the table, and you can give it the name of one key that you actually want to be displayed itself. So I'm going to do the same console.log that I was doing before, and now when I refresh, instead of seeing all of the keys that are out there in the object, here are all of my keys itself, and then these are just inside the object. These are the individual keys that I'm actually displaying. So if there's only certain things that I want to look at, I can do this, and it makes it a lot easier. Instead of trying to display an object that might have 50 items in it, I can just pick out exactly what I want and be able to display it. Now that's great if I only want to display one value. What if I want to display 2 or more values? Well, you end up using a different format that you do. So if you have one, you can just give it the name as a string. If you want to do more than one, you end up doing an array. Actually, we'll go ahead and do them both at the same time. You do it as an array, and you give it all of the ones that you want to be displayed in the array. So when I come over here and refresh, here's the first one with just a single value. Here's the one with multiple values. Now, when you display things with console.table, whether you're displaying an array or you're displaying an object, to make things easier, you can actually click on these headers at the top of the table and be able to sort it. So we've got Bob, Sally, and Amanda, and if I click on it, it sorts it in ascending order. If I click on it again, it sorts it in descending order. So I can do either one to be able to display it in either direction. So that's a built-in feature that you have, within, using the console.table itself. All right, so that's so I've already talked about the first 5 that you can use for debugging. Then you can also use the console.table, which is a 6th method, which makes things a lot easier to actually view things in the dev tools so that you can actually use it. Now, let me show you a 7th way, a 6th, well, we've done 5, 6, so now we're on number 7. So there is also this thing that's called console.trace. At any time, if you want to see the history of the execution of your program, you can put in your code, like I have at the very top, this console.trace, and it will actually print out that information for you. So it will give you that stack trace history. So you don't have to wait for your code not to break and then get the console, the stack trace pointed out when your code breaks. You can actually put something in while you're writing your code to make sure that the execution is executing exactly like you were expecting it to execute. So what we have here is I have 3 functions. I have add, calc, and main are my 3 functions. And then at the very bottom, I actually call the main function. So when you start looking at this and the way that it's going to work, this is going to execute for main. It's going to call main. Main's going to call add. So you start here, this puts this into the stack trace. This is going to call add. So add's now going to be added to the stack trace. It's going to return, so then it's going to come down here and it's going to call the calc function. This is going to now be pushed into the stack trace. This is going to call the add function for the first time here. So this is add's going to be added to the stack trace again. When that returns, this is going to pop off. It's going to call add again, so it's going to put add back on there again. That's going to return. It's going to say, okay, I'm done. So that's going to be removed. This is going to be removed. And it's going to come back over here and it's going to finish. And then you're going to end up with the end of the stack trace. So when you look at it, this is what you're actually going to see. Because it's calling the stack trace, every time it gets into the add function, it will basically point it out. So all the times that it was doing that, multiple times, you can see where it's giving you 3 different stack traces on the screen, and you can see how everything starts. And it always starts with anonymous because we start with the global scope, which is the window, and then you start main, and then you start to see as it starts calling things, and it gives you that stack trace. So this is a good thing to be able to have and to be able to use. Now, another thing that you can reason on, why would you use like a console.trace method instead of like a console.log? Well, one of the main reasons is that how many of you have a rule that when your code goes from development into production, you're not allowed to have any console statements in your production code? How many of you have that as a rule at your company? We have that as a rule because when we have a production code and people are using our application, we don't want all this stuff being printed out in their dev tools when they're running a production application. So if you have console.log spread out in your applications, and most people have applications that are based on multiple files, especially if a very large enterprise application, you're going to have multiple files that are going on in different locations and everything else like that. And you might forget to pull out a console.log in one file or another file. So you need to be able to go back through and to pull all of those out when you're running your code itself. If you do a console.trace, you don't have to put it in every one of these. Like I did an example that had 3 different methods that I was using, and then I started off by calling the very first method. I don't have to put a console.log in each one of these methods so I know, I was here are the values that I want to print out and everything else like that. I can put in one console.trace and I can see that whole history that's on there, which means that I only have one line that I need to remove before I can move my code from development to production. So console.trace makes things a little bit easier. It will give you a lot more information than a console.log itself will give you. And then also it gives you the information about what files were being called. It gives you the line numbers that it was being called from. Sorry about that. And it gives you more detail than you would ever get with the console.log. Because if you had a console.log in a file and it printed out in the console, you don't know which file that console.log was in. But a console.trace will tell you where it was called from, so it can give you that information itself. Now, the last thing that I want to give you on what you can do to make things easier when you're debugging your code is actually to use debug. So if you want to know where certain things are were being run, or what file that they're being run in, is that you can have this thing that's called debug. So let me break out of this, come back over here to my code. I have these 5 JavaScript files that are called where is it 1, 2, 3, 4, 5, and I'll show you what just one file looks like, because it's pretty much the same thing in all of them. In each one of them, they have these functions, you know, F1, F2, 3, 4, and 5. There's only 5 that are in each of the 5 JavaScript files, and it basically just gives you a console.log to let you know that, you know, you're currently in function 1 itself. So if I come back over to my browser and I refresh, I can actually execute function 1, and it gets the console.log that says that I'm in function 2. If I want to do function 2, it will tell me where function 2 is, and it will give you that information. So it gives me the console.log as a result of what's in that code. I have no clue what file that function is contained in. I just know that the console.log that was in there, that it resulted. So what you can end up doing is you can do, let's say, debug and do, let's say, function 31 and put that in. Now, when you first do that, nothing happens. And what it does is it's basically equivalent to putting a breakpoint on that function, so that when it executes, it will stop executing, open up the file where that is that function is contained, and put you at the start of that function so you can see what's going on. So I'm going to actually execute function 31 now, and I'll show you what the debug thing does. What it does is it stops. And you can see here at the very top, it tells me the name of the file where that function is actually contained in, so I can easily find it. And then it puts me at the start of it. And then over on the right, it should actually give you the line number in the file itself where it's executing. So that's a great way of using debug, so that you can actually go out and debug your code while you're working on it. And a lot of people will, instead of using a console.log, because if they put them everywhere, they might forget to remove them before their code gets pushed over to production. You know, so sometimes they transition over to using the console.trace, because then it's just one line and they can debug it. Well, with debug, you can actually debug your code without actually putting anything in your actual code file itself, and you can actually do the debugging directly in your browser itself, and then you don't have to remember about removing any of the codes. Did you have a question, sir?
Yes. So will it work for the production code, like when you go through the optimization, like, production code usually doesn't look like that. It's compressed. So will it work?
You know, I do not know the answer to the question, because I've not tried that on the production code, because I've always done it in development. But try it and then report back and let us know. So let me get back over here to my... So when you go through and you look at debugging your code itself, understanding how the stack trace itself works, once you understand that, you can look at the log and see how things are being put in. You can use all the different console methods and stuff like that to do the debugging. You can debug directly in the console itself without putting anything directly into the code itself. So the first question that a lot of people ask is, why do errors actually occur in your JavaScript code? JavaScript has certain errors that they will stop if something happens. These are some of the names that they've given to the most common errors that you will actually see that are out there. So why do errors occur? Usually it's a result of, mainly the number one reason, it's the result of bad data. You might be expecting a string and you get a null input, so that will cause a problem. you might be trying to access something that's an array that has 5 items, and you might try be accessing the 7th item in the array. So that index doesn't exist. So that will cause an error message. Another one would be if you were trying to do an AJAX call to go get data from the back end, and when you were writing the URL for your AJAX call, you just might have fat-fingered typing in the URL. You might have put just HTTP instead of HTTP or something like that. So therefore, it's trying to call a URL that doesn't exist. So that will end up generating an error message. But normally, your errors happen. It's something that happens because of bad data, or somebody's using it in an environment that you haven't tested and you're not aware of. So how do you handle capturing errors like this when you actually take your code and you roll it out into production? Because a user might be trying to use your app in a manner that you didn't think that somebody would use it, or they're using it on a browser that you didn't get to test on. They're using it on a device, whether it's a computer or a tablet or a mobile device on a phone that you don't have, so therefore you can't test on it. So they might have an environment, because of what they're using causes your application to break in their environment. So how do you handle when things go bad in production? Well, you can basically go through and actually capture all of these errors that happen as your users are running your application and be able to have that information sent back to you so that you get it. So the way that you can do that is in your application, you can put an on-error function, because remember, everything starts in the global scope, which is window. So you can basically put in there a on-error function. So if an error occurs in your application that's not being handled, it will result in a stack trace being put into the console. What you can do is you can actually put a function, something like this, inside your code. And inside that code is you have that function that you can put in things like, what file that you're currently running in, what line, what column, exactly message and everything else like that. And you get the error that occurred as a result of the on-error method being called. And what you can end up doing is for this example right here, I just put in a console.log where it actually console.logs out the stack trace. But what you can do in your application, whether it's a web application or like a mobile application, is you can actually put code in here where it connects to your server at your company, and that server will just be expecting you to send a dump of the stack trace of what happened. So you can see exactly the execution of what happened in your code for this user when it crashed for them. So if a user calls up and says, I'm trying to use your application, and it crashes, and they were like, well, what were you doing when you were trying to do that? By putting this information and sending it over to your server, then you can actually store this in your logs that you just go through on a regular basis to see why things are crashing as your users are using them. And because you have access to the window, it gives you an access to like the navigator, so you can find out what browser they're using, what type of computer they're running, what version of the browser that they're running. You can get the stack trace and everything else like that. And you can just send these, and this could just be a put method that you send to a server that you have that's in a publicly facing server at your company. And it puts it out, and it basically sends all of that data to the server. Server writes it to the database, and then you just go through the database, and you can see if there's a consistency that people are going through this step, this step, this step, and it crashes, and you're starting to see that pattern over and over, then you can see exactly where you need to go in your code to be able to address that. So this is something that's very easy for you to put in and get exactly what the user was getting when it crashed and burned for themselves. So if you did want to do it in an on error, you can actually do the exact same thing by doing it through an event listener that you can just add into your code itself. And what you would do is basically the same thing. Is inside that function, you would connect to your server, put all the data so you know what browser they were using, what computer they were using, what version of they were using, and everything else like that. And, the stack trace. And so the stack trace, it tells you the exact steps that they went through, and where it died, it was going to tell you what file it died on, what line number it died on. So you can see exactly where it is in the code that they were having problems, and then you can go in and make adjustments to your code to account for those error messages that customers are getting. So you can do as much as you can debugging while you're in development. You can use all the different console methods. You can use the console.table to be able to display things as you're going through and debugging. You can do the debug itself. But once you put it out into production and it doesn't work for somebody, you're like, well, unless you're just sitting there watching them, you don't know. By putting something like this into your production code, you can get access to them. And it's like you're literally looking over their shoulder as they're doing your app, running your application, and it crashes on them. So that's another thing that you can consider when going through and debugging your code, so that you can handle things that people are experiencing problems when you roll it out into production. So that's the end of what I wanted to cover. So we're back to the beginning of my 3 truths and 1 lie. So the 4 items right here. So the first one, how many of you think the first one is not true? Okay. How many of you think the second one is not true? Okay. How many of you think the third one is not true? Okay. How many of you think the fourth one is not true? Okay. The one that is not true is the second one. I didn't have a 4.0 GPA. It was a lot less. But the other ones are true about myself. So thank you very much for attending my presentation. If you have any questions, let me know. I appreciate all of you attending the inaugural version of .NET South Conference. Hopefully Pratik grows this into a much bigger conference every year. So he also does a series of other conferences. So how many of you are here locally from Atlanta? Okay. How many of you have ever heard of Connect Tech Conference or DevNexus? He does quite a few other conferences that are out there. So be on the lookout for some of his other conferences. But does anybody have any questions? Yes, sir.
Back to the stack traces. A lot of times when I look at this, it has a lot of anonymous functions or entries, and it's really hard to understand what's going on, especially in fallbacks, which most of the errors that's where they happen. You have some kind of fallback, you get anonymous response. It's hard to track what actually originated that fallback. Do you have any advice on that?
Well, usually what called the callback is usually what is in the stack right below it, because it's going to pull things off from the top to the bottom. So, for example, if you start off and you call a function get data, where you're going to get data from the back end. Okay, so that's an async function. So that's going to be put into the stack trace. So you have get data is at the bottom. While it's waiting for that, it's going to keep moving down your code. So the next thing in your code, you might have something that would be, count numbers. You have a function. So count numbers is put on top of that and everything else like that. Then you might have another function to display header or something like that, and that is put on there. And then the get data returns and everything comes back to it. Well, what it's going to end up doing is it's going to come back into the thread, and you will see the get data again, so that you can see where it comes back to it. And then it pops it off, and then it continues displaying the header information that is on there. Does that explain that? Yeah, but usually if it errors out, it should give you the file and the line number. So you can go in and look at that third-party product that you're using, that library, and see where it is in their code that might be causing it. Yes, sir.
So when you type in debug function name, is that equivalent to breakpoint manually?
It's almost exactly the equivalent of putting in a manual breakpoint so that you can actually add things on the fly in the console, and then you don't have to worry about putting it into your editor itself to put the breakpoint in, or actually putting the word debugger where it manually will stop. So you're just basically doing your debugging on the fly at that point.
So in the case of the same different files maybe with the same function name, how would that be resolved?
So say that again?
Say maybe we have different JavaScript file, right? Maybe they have same name function name, or maybe inside some export class. How that function name is going to resolve when there's a conclusion of the function name.
So you mean when it has the function inside an enclosure?
Yeah. Well, and also the function name maybe they might even enclose the same function name.
All right, so if you have a function, let's say a recursive function or something like that, so you might have like, I don't know, a function that would be like some numbers or something like that, and as you're going through the function, you actually have a function inside this function itself, and your code will go along and will call that function, and then it comes back out to your code, goes along, you call the function again, and it comes back, but the function is embedded inside the original function. Is that?
No, sorry. When you asking the debug, when you're doing debug function, so in that case, how do you resolve the function name?
So I know what he's asking. So he's saying that he has two files and he has the same function name. So how the debug will work with that?
Yeah, how do you know which function is called separate?
And they both have the same name? I would think that would give you an error by having both of them with the same name, because otherwise how would it know which one it is that you want to call if you just say call, get some or something like that. So you've got to have something in front of them that distinguishes between calling get some that's in file 1 versus get some in file 2.
You can always qualify, I guess. Namespace? Yeah, namespace.
That could be. I'm not sure. I've never tried it where I had two different functions with the same name. So don't know the answer to that one. Okay. All right, any other questions? All right. Thank you very much for coming.